So, without further ado, Jelte, could you please give us our latest insights into 5G and how it could help companies connect their things in a very, very soon future?
At Telenor Connection, we have a global connectivity solution, and we give the connectivity. We give you one point of contact, one invoice, and one integration point for all your Internet of Things worldwide. But we are not here to talk about Telenor. We talk here about 5G. I would like still to mention the global connectivity a lot, because the things that we will focus on is global connectivity that we are working on together with you. What does 5G mean for us? And for that, we have actually a very simple presentation in 3 themes. We will talk first about what is 5G, because there's a lot of buzz in the market. There's a lot of hype around 5G. Some people are even scared about 5G. 5G is very fast, 5G very slow with battery savings. What is actually 5G? And how does it work? To have some technical fundamental knowledge about 5G is important to understand the implications on your architectures. But also, when can we start using it? Because when you just read on the internet, it looks like 5G is available today, but some aspects of 5G are there and some other aspects will follow later. And we will try to show you that how that works from a deployment point of view and when you can start using it. But first, what is 5G? We see 5G as an evolution of existing technologies. 5G is not this revolution that will completely change society. No, this is an evolution of the Internet of Things, an evolution of that started with telemetry. We started with connection with telemetry in the 1990s, telemetry on 2G and 3G, where we used the telecommunication networks that were built for humans. We also used it for the Internet of Things. So we were piggybacking on the existing technology. But now with the Internet of Things in 4.5 and 5G, with the mobile IoT, we have the first true IoT technology, a technology that's really made to make the connection of the things easier and to let you be able to do more things like long battery life, very fast and response, etc. And you can see that there are 3 aspects of the 5G. The first aspect is the mobile IoT, that is LTM and narrowband IoT. These technologies are 4G technologies. They are building on 4G LTE technologies, but they are forwards compatible with 5G. And these technologies, LTM and narrowband IoT, they are a good technology to think about when you would like to have your devices for the next 10 years, when 5G is available, to choose those technologies, to consider those technologies. Another aspect is enhanced mobile broadband. And enhanced mobile broadband is what everybody is talking about. The new iPhone 12 that launched with 5G support, it's actually just enhanced mobile broadband. It's mainly for consumers, makes everything much faster. You can send much more data to your devices. And then the last one is critical communications to give a very fast response. Let's dive into details at these 3 different themes. We're starting with the mobile IoT. That's very relevant because mobile IoT has been launched in the recent years already. And for example, we have seen recent launches in Germany and Austria, where the LTM technology is nationwide available. And what can you do with it, right? Why is it there? Well, the theme of here is to do things simpler. So less is more. Just imagine here, this is the device. This is in my office, my home office. There is a device, it's a fire alarm. It is a very simple device, a very important device. So I always want to have it connected. And you could put a SIM card in this one. And you could have a narrowband IoT or LTM connection with that. It's a simpler device. The device, I don't want to change the battery of the device every day, right? I have also a phone here. My phone, I need to charge it every day. Yeah, it's fine for a phone, but not for a fire alarm. So for these kind of use cases now, there are battery saving technologies available, and they give you a longer battery life. So you can have this device up there for 10 years without changing the battery. Then also it can give you better indoor coverage, because indoor coverage, especially in parking garages, etc., with 4G, it's not always, let's say, optimal indoors. So these technologies have special things like repetition, changing signaling strength to penetrate deeper into buildings. And also they are simpler and more efficient, so it's easier to mass produce and mass deploy. So how does this work? So mobile IoT is a matter of trade-offs. Since we have, we have certain rules in the physics, right? So we have certain trade-offs we need to make. We need to balance the battery life versus responsiveness, because how does it work? How do I get a longer battery life? By doing less. So a little bit advice to you. I already know that, of course. If you want to live longer, do less and sleep more. Very nice, isn't it? So your devices, they don't roost much, so they can sleep a long time and they have a long battery life. But yeah, if they're sleeping, you cannot call them, right? This fire alarm is perhaps all the time listening if there's any fire ongoing, but it's not connected to the network, or it is actually a little bit connected to the network. It is sleeping while connected to the network. Then you cannot send the signal to the device because the device is sleeping. In other words, it will not work if you have to make a phone call with that device and receive a phone call. For other devices, you would like to have very fast response. For example, if you expect that I press a button here on my device, and when I press the button on the device, that device there on the top reacts immediately, then it better not be in sleep mode. So it's like a trade-off you need to make. And the nice thing is that you, as an IoT developer, as an IoT company, can choose and tweak what kind of level that is best for your use case. Perhaps your use case is that during the day, you would like to have the device very responsive, but during the night, you just let it sleep. Or you like to let it sleep for 1 week and then send some data. It's up to you. And similar, like you have the indoor coverage, it happens with repetitions. So I can repeat myself, and I can repeat myself again and repeat myself again. If repetition is if you're explaining something, repetition is actually very important because you're easier to make yourself understood by the audience, right? It's a pedagogic thing, but in network communication, it's the same. Repetitions give more possibility to actually reach the device, but you understand it becomes slower. Repetition makes things slower and takes more battery life. So here also this what kind of trade-off is good for you. So you can tune this kind of parameters, and then you can find this best. So this is IoT technology, the first true IoT technology that is available on 4.5G and will be available during the 5G. The second part is where everybody talking about. That is the enhanced mobile broadband. That is the newest iPhone there, the newest iPhone 12, but also the Android devices, of course. I have already that for a longer time. They now support 5G. So what is that then? That means basically you can send much more data. Is that relevant to send much more data for consumers? Basically, yeah, it is very relevant, but it's mainly targeted to consumers. We can also use it, of course, in the Internet of Things, but consumers is the first focus of this one. Still, I think for IoT, we can do a few things like this remote working. Now, we have all learned to work in a new reality of remote working. Like now, instead of I would have liked to meet you in person in a room, we can have good discussions and so on. But right now, it's just one screen and I'm talking. This is the format of today. We can, of course, fix other sessions for you later to have more personal approach. You can contact Christian for that. But if you have many people talking at the same time, perhaps you notice that the quality of the complete video conferencing is very much determined by the fastest or by the slowest participant. If everybody's on 5G, you can do much more things with remote working. But it's not just for work and pleasure. It's also very possible to think about remote maintenance. This is an IoT use case. Just imagine you are producing machines. Your machines are being shipped all over the world. You have no idea where they end up, but they might end up in the United States. This lady here on the picture, she is the expert of a certain technology in that machine. So if the machine has a problem, she can fix it. And it's very difficult to find somebody else that has that knowledge. So before COVID-19, what did we do? That kind of people were sent all over the world to fix machines and do some specialistic stuff and go to different places. It's very expensive, and also now the society has changed. This kind of traveling is not so normal anymore. So with this new technology, the massive streaming, you could do things like you have a local person sitting there in the United States, a skilled engineer, but not a specialist, and then the lady, she is the specialist. She can tell the local repair guy what to do, and together they can have a very good video conference about that. The machine is always connected because it's global connectivity. Easy. That is a use case that might grow fast, especially now the world has changed. But also more classic things like you have of course some advertisements boards in retail customer support. We see a lot of shops, retail shops, they are moving to the web, and still you have shopping centers. Perhaps you have something in between there, and we can think about it. But enhanced mobile broadband is important to talk about because here is everybody is talking about. It can be relevant for us as well in the IoT. I think you are much more creative as you are all entrepreneurs here in the meeting than we are. But now you will have the possibility to send much more data. So how does this actually work? So this works in a different way. This is completely fundamental different than the previous one. The previous one we said we slim down, less data, less antennas, and longer battery life. Here we do the absolute opposite. So this is an Android phone. It has, I think, 1 or 2 antennas. You know, recently we have 2 antennas in the 4G, but now we add much more antennas. So we add more antennas, we can send much more. Have this short battery life, I would say as well, because we use much more power. And there's another thing that's interesting. This is called beamforming. And what is beamforming? Now, if you look at the normal cellular communication, then you have a cellular tower, and it sends radio signals inside the cell. And for the German speakers, look for the Sendung mit der Maus on this topic. It's fantastic. It's an old one from the 1990s, I believe, but it's a fantastic introduction to cellular technology. It's really recommended because this is how actually cellular technology works. Radio waves, they move into a cell. And then everybody in the cell gets a kind of similar signal quality. But what beamforming does, it positions straight, it makes a logical communication channel because there are more antennas and there are new technologies between you and the device. So each device has its own radio signal. And that, ladies and gentlemen, makes the communication much more efficient. But there's also a problem because the communication doesn't go as a wave through the whole cell. You can have something that obstructs it. So here you see on the right hand side a connected car which is not connected here, you see, because there's a building in between. So what is the solution? Well, the solution is more smaller cells, especially in cities. Now the good news is that you as somebody who likes to connect things don't have to care because the handover goes completely seamless, like you are used to that, right? You're used that the connection goes between cells seamless. And this is also going to evolve into smaller cells and much faster data transfer, especially in cities. And this is actually the moment being deployed. The last and important part of 5G, where there's a lot of hype about, is the critical communication. And we believe the word critical is a little bit unfortunate, but this is how the 3GPP have called this, or the GSMA. But critical means, of course, all data is critical for you, but we mean here critical things. You can do things that need ultra fast response. The ultimate example and a kind of dream of many in the industry is self-driving cars. Just imagine, instead of standing in a traffic jam, the car drives you to work. Yeah, this kind of use case is also a little bit unfortunate that there's a lot of hype about this, but does this really become reality? We don't know. Look, for example, today I read on the internet that Uber the American company, have decided to not continue with their self-driving cars prototypes and so on. They have tried it, but they say that we don't do that. Still, self-driving cars might be there, but on the public road is questionable. However, there are a lot of use cases still there you think the critical communication can help. And they are especially inside certain areas, like your factory floor. If you're producing, for example, you're producing a lot in the German-speaking countries. If you're producing, for example, a complex car or something, or a machine, there are many robots. They work together to build that car or build that machine. These robots, they communicate with each other, and they must be very fast, so they can actually do things very fast together. And they can actually see if your production is always the same, and the robots does always the same, then you don't need that, of course. But just imagine there could be small variations that the robot needs to make a small change, very fast, need to make a change, communicate to another robot. Hold your horses, I'm not ready, I need to first make the change. So there's communication between robots. That we sometimes talk about that in Industry 4.0. Those kind of use cases, they are really relevant. And you can think about, yeah, but factory floors, I have a factory floor, why should I use wireless communication? I have cables. Yeah, cables are nice, of course, but a cable is often connected to a switch, to a modem, to other things, and things can break in between. And wireless communication, especially the mobile technology, is very stable. Another example, you might have a container harbor where no people are involved, but containers and trucks, they communicate with each other to load and unload containers. So this technology is very useful where you have message streaming, where machines cooperate. So how does this work is a question. The first is, of course, how fast can you make it? Well, the highest speed we can think about is the speed of light. And if you want to have, let's say you have two devices, you have two devices, and they communicate with each other, and to have 1 millisecond between them, maximum 100, 150 kilometers. Otherwise, it takes 2 more milliseconds, right? So what you need to do is then you need to have a kind of decentralization approach. We have been, as companies, moving all our data and our efforts to the cloud, centralizing that in the recent years. And why did we do that? It's cheaper to deploy things in the cloud, easier to scale, and so on. But now I tell you to decentralize. A little bit weird, but that is needed. If you want to do fast communication, you must make sure that you use a technology that the network, but also your data, your architecture is built for that, but our network is also locally to you. So you have a lot of small local edge cores. And these edge cores, they are of course connected to a central cloud, because a central cloud is still there and it will not go away. Because a central cloud is of course cheaper for many use cases where, yeah, the response time of 4G is good enough. So this is a new thing, and you understand this is much more complicated technology. It's not just changing a SIM card and a module. You also need to change your architecture. So this takes a little bit more effort, both from us and from you, to get this done. And therefore, I think it's good, with that in mind, to think about when can we start using this? When is this ready for prime time? Well, here we have a forecast, and forecast means that we think that this is going to happen. And we look at it here from a global perspective. So not when can I use it in Germany, or when can I use it in the Netherlands, or when in Sweden. No, it's when can you have global deployments on this. Of course, depending on which country you're deploying, things might go faster or slower. So the first part is the mobile IoT. As I said, it's available today. In most developed countries, you have LTM and narrowband, or sometimes LTM, or sometimes narrowband. And that's available today, so you can start working with it today. Then the enhanced mobile broadband, that's the consumer part of the 5G. Yeah, it's getting available today. Often in cities. Nationwide deployments are a little bit more scarce. But they are there, but it will take some years. We believe that around 2023, we can see that you can say, well, global 5G is something that you can use. Because it's not only that it has to be deployed, but there must be roaming, must be agreement, there must be devices that are relatively okay. It's in the beginning, of course, devices also have to go through a maturity stage. Think about that. And finally, the critical communications, it will take a little bit more time. The 5G critical communications that are out there today, they are mainly pilots. So we are testing ourselves here in Sweden together with a network vendor and together with an industrial partner to test local 5G networks, to test this ultra low latency. We're doing that, and so do all the operators, but there are no commercial deployments. So you as a company, if you as a company would like to deploy something today and connect something today, it's a little bit too early. But if you as a company think, what is relevant in, let's say, 5 years from now, it's good to look at it. It's not something to today purchase. If you need connectivity today, then actually the mobile IoT or a normal 4G is a very good alternative, and 5G is coming there very soon. A little bit about the deployment, because there are different ways how 5G is being deployed. So they are the first phase in how typical network operators deploy 5G is to have something called 5G non-standalone. And 5G non-standalone means that it works similar like with the hybrid cars. You know, in the beginning with the hybrid cars, the first car that was there had a petrol engine and a very small electric engine. So actually it's just a petrol car with a little bit of electricity, because it sounds good to be on the electricity. Now it has changed. Now we see real electric cars with a little bit perhaps helper engine in petrol. Now, this is similar kind of approach we see in 5G. The first one's non-standalone is actually just 4G. Yeah, it's actually just 4G. The whole anchoring mechanism, the whole control plane, as the telco engineers call it, that's all 4G. And then 5G is only needed when it's when you need it. You can also get a little bit 5G. The second phase is that you see 4G and 5G starting to be used in the radio band, in the same radio band. The radio band, you understand that is the auctions of the radio frequencies are very expensive. That's actually one of the major costs of telco operators in the world, right? So you would like to make sure that you don't waste any band. So in the beginning, 4G and 5G will be used in the same band. The nice thing is that you then can have 5G only devices, because in the first step today, all the known commercial deployments around the world are this non-standalone, and you still need 4G anyway. So what do you gain? You don't gain any efficiency benefits, but you can gain speed, but still you need two modules or a module that supports both. In the second phase, you can have 5G standalone. And then in the third phase, you have them on dedicated radio bands. The intermediate step is needed so operators can stepwise say, okay, start with only 4G, a little bit 5G, and then slowly have 5G only with a little bit 4G. But it's not so very efficient, dynamic spectrum sharing. That's what we hear, at least. So some people say it's not so efficient. Some people say it's quite good. But let's say the most efficient would be to have 4G and 5G in their own bands. And that is the final phase. Then you think, of course, like many of our customers that have a long-term things, what happens to 4G? We believe that 4G will stay available throughout the 5G life cycle as well, because it's very efficient, especially on the lower frequencies that's used for coverage. Look for automotive use cases, for example, telemetric cases, they will still be available on 4G for a long time to come. So the LTM narrowband IoT will be available for a long time to come during the life cycle of 5G, we think. Of course, we cannot guarantee, but we think that is going to happen, because that's where the volumes are in the IoT. Whereas if you have the critical communication, you need the higher frequencies, and they will be 5G only. So what does it mean for you? It was a lot of information. As always, we can talk for hours about this topic. We can do that in other sessions. You can go to our homepage and read more about it. See this one more time. Download the white papers about this. The first 3 points that are important for you. 5G is there very, very soon. And enhanced mobile broadband is what the consumer is talking about. That is available very soon. That is the first step. The critical communication what everybody is talking about, if you would like to use it today, yes, for testing, no for commercial deployments. It takes a while before that technology is mature. And, ladies and gentlemen, think about also there the business case. The SIM card and the technology is only a small aspect. It's a more complicated than you think. It's not just connecting and then you have critical communication. You also need to think about your own infrastructure. And the third point, consider the LTM and narrowband IoT. And especially for global deployments, LTM has the best cards there because LTM has better bandwidth to support the device, especially device with a very long life cycle. So we have dedicated sessions about LTM and narrowband IoT that you can go to our homepage and look at. I can download the white paper and watch the webinars about that. But that's not about this. Today we talk about 5G. So I hope that was interesting for you. Please, Christian, hand over to you.
Ja, vielen Dank, Jelte. Also wie immer sehr interessant, dir zuzuhören. Vielen Dank auch an Sie für Ihre Zeit. Ich hoffe, es war interessant und auch relevant. Und es hat auch ein bisschen Spaß gemacht. Ich wünsche Ihnen noch einen schönen Dienstag und bis bald von uns. Tschüss und hey do.